Hello and a very warm welcome to the first expert talk of the day. Parker Hannifin is proud to be the global leader in motion and control technologies. And here at Bauma, the motto is technology inside that moves your world. Parker is here to fulfill your wildest engineering dreams with rock-solid solutions for your off-road machinery and your mobile machinery. Here in our expert talks, we have gathered experts from all over the globe, and they're bringing their insights, their expertise to us in the topics that are driving the industry. And those are electrification, digitalization, clean tech, and mobile hydraulics. So I'm delighted now to be joined by our two experts, and it's my pleasure to introduce them. First of all, we have our clean tech expert here at the booth from Parker. He works at the Engine Mobile Filtration R&D Center in Stuttgart, and together with OEM customers, you lead projects for the development of filtration and separation solutions for fuel cells and hydrogen combustion engines. Please give a very warm welcome to Robert Jozsa. And joining us from the UK, he created the Hydrogen Systems Group at Haskell when you were general manager and president of Haskell. And you were responsible for designing, engineering, and manufacturing hydrogen compression and refueling systems. Now you're an independent consultant for hydrogen projects across the globe. I'm delighted to have Stephen Learney here with us too.
Thank you.
So, fantastic to have you two experts here. We're going to be exploring hydrogen as an alternative, a zero-emission alternative for off-road machinery in agriculture, construction, mining, and also the challenges it poses for distribution, right? So, we had a LinkedIn opinion poll. And in that opinion poll, we asked, what do you see as the future energy for off-road mobility? So I'd like to see a show of hands. So we'll compare the results in just a second. Who thinks it's electrification will drive the future of off-road mobility? So we got one taker here, just one. Raise of hands, who thinks it's going to be electrification? Just one, okay. Hydrogen fuel cells. A few more there, okay, interesting. Advanced diesel. Anyone think it's advanced diesel? Nope, no takers there. And optimized ICEs. We've got a couple of few there too. So, Robert, what do you think? Let's see, what was the actual result on LinkedIn? Right, hydrogen fuel cells was definitely in the lead. And how do you think that compares to the answers here?
It does compare a little bit, and it's interesting that we saw these results online. I was also expecting electrification.
Yes,
but,
I would have thought so too.
I'm hoping hydrogen is a big player. But you can see here, it's divided. So hydrogen is definitely be part of this change.
So you're in the right area, definitely. Okay, thank you for your answers. In the context of decarbonization trends, what significance do you think hydrogen has for construction, mining, agriculture, and so forth?
Yeah, so of course the target is to have clean air and clean tech. We need to make sure that decarbonization is coming and we are using renewable fuels. There are a lot of pollution which are coming on from all the sectors. Transportation sector is a major polluter. So that we have stringent regulations there targeting CO2 emissions from the fleets. This is still missing a little bit on the off-highway segment, but we see a lot more pressure to make sure that this is slowly changing. And this sector is very complex. We have a lot of different machines, small machines, large machines. So there are different factors which will influence this change and which technology will be best. So part of these factors, we have efficiency, for example, and we need to make sure that you are utilizing the most efficient technology because this will impact your total cost of ownership. We have uptime of the vehicle, whether it needs to run for very long hours in the day, like we have harvesters in the summer, which run for long periods of time, or the operation is more in cyclic. We have mobility of the equipment, if it needs to travel long distances or if it's more stationary. This will also impact which technology you are using.
And sorry to interrupt just briefly, are you saying that hydrogen is more suitable then in comparison to electric battery vehicles in those cases?
Yeah, so for example, if the equipment needs to run for a very long time, you will not really have time to recharge the vehicle, and that will have an impact. Similarly, if you are running long distances compared to stationary, where you have other options which might be more suitable for those applications. And I think one of the big points is also the power rating of the vehicle. If you go outside, you can see the machines which we have here. They are huge machines. If you want to use batteries for those, you are going to need a lot of batteries to be able to store that energy. So there are other options, clean options that might be better suited here. And I think hydrogen is going to be part of these options, whether it's fuel cell technology or hydrogen combustion technology. That's to be seen, but it's definitely going to be part of the selection.
Okay, so if I understand right, despite its complexity in handling, power and range are definitely two advantages of hydrogen. Is that right?
Power, range, and again, how much time you have to recharge it. How often do you use it? Do you have time for the recharging or battery swapping? Those are definitely going to impact the choice.
Okay, anything else that you'd like to add to that, Stephen?
Yeah, indeed. Thanks, Robert. That's a good lead in. Indeed, uptime is critical. Most of this equipment is an asset to a business. You really want to keep it running 24/7. So yeah, to add to what you're saying there, that I've seen a lot of electrification around this site as well, and like you say, it seems to be targeted predominantly at the smaller machines. And I'll talk a bit about why that would be. But equally, I've seen a lot of activity around hydrogen as well. A huge number of companies who've got internal combustion engines or almost ready, and some are ready for using hydrogen now. And when you think about the applications for getting to zero emission, electrification makes absolute sense because the infrastructure is there. It's easy to implement that infrastructure use.
Is it though, Stephen?
It's relatively easy. There's very little in terms of technology development to be done in order to make it ready. It's more a scale thing about rolling out infrastructure and the costs associated with that. Okay. So in that context, then yeah, electrification is relatively easy. But as Roel was saying, there are vehicles out there and uses out there which just are either uneconomic or impractical to use electricity for. And that's where really you've got to look at something like hydrogen as the zero emission alternative to
Can you just give us some examples where you think it's definitely impractical?
Yeah, there's a specific one which has been around now for well over a decade, and that's forklift truck fleets used in large warehouses, where there's a lot of these now which have been converted from whatever they were using before to running on fuel cell hydrogen. And indeed, businesses like Plug Power and 1H2 have managed to make successful business out of those cases. So it's a proven case.
Mm-hmm. Yeah. And as far as emission reduction is concerned, do we have some comparison there between hydrogen and electric? Because it depends where your electricity comes from, right? And the mix there.
That's where it all starts. Sorry, Robert. The start is where you're getting the electricity from. Today, hydrogen is vast majority is manufactured using steam methane reforming, which is taking methane, so it's not particularly green. Progressively, as we use more renewable energy power, you can take the electricity from that in order to electrolyze it and produce hydrogen as a genuine green solution.
Okay, so it can get to the same emission reduction as in comparison to electric battery vehicles. Okay. Yes. And do we have the numbers to compare that?
I don't have the numbers myself.
Not here yet, but they exist.
They will
today.
Be out there somewhere, yes.
Okay, so hydrogen seems to be a viable solution. What strategies can be put into place to ensure its availability at the sites that we've been talking about for construction, for mining, or for agriculture? And perhaps are there differences in those?
Yeah, and that's a question which comes up quite a lot. How are we going to get hold of hydrogen where we want it, when we want it? There's actually more options for getting hydrogen to its point of use than there are with traditional fossil fuels. So just like petrol, diesel, methane, you can transport it via a tanker or on a thing called a tube trailer via road, or you can pipeline it, so just the same. But in addition to that, you can If you want to move hydrogen over long distances, there's a process called sequestering where you actually create a stable compound from hydrogen, such as ammonia or a metal hydride. And then that's very suitable for transporting, for instance, via ship over very long distances. And then finally, what you can't do with fossil fuels typically is you can make your hydrogen at or close to the point of use where you want it by associating a renewable energy with electrolysis with water to get your hydrogen at point of use. So yeah, a lot of different options there.
And as far as the distribution is concerned, does it make a difference whether it's for fuel cell technology or for hydrogen combustion engines?
None whatsoever. And taking those different solutions for moving it, if you want to move it by the most common way of moving it today is through a thing called a tube trailer. So you have gas under pressure, you transport it over a road, and you deliver it to where it's going to be used. That's, like I say, used on virtually all the stations that are out there already. You can also move it as a liquid. However, to do that, you've got to liquefy it, and then you've got to store it cryogenically. And that's a well-known method that NASA have been using, for instance, for 60, 70 years. And in recent years, we've seen the state of California convert most of its existing hydrogen refueling stations from gas to using liquid. So again, a quite well-established way of getting hydrogen to point of use. Pipeline is increasing in the amount of use you're seeing out there. And there's already over 5,000 kilometers of hydrogen-dedicated pipeline in use. A good example is in China, where there's a station just north of Beijing where they were taking hydrogen via tube trailer, but the logistics of how much hydrogen they needed became a challenge. And so they built a 20-kilometer pipeline between where the hydrogen was being produced to the refueling station, which is then refueling a whole bunch of city fleet vehicles. Similarly, in Xi'an city in China, they've done the same, and that particular station is supplying a couple of stations which are supplying mining vehicles, very relevant to where we are today, and also other public vehicles. So pipeline is becoming very common. As far as sequestering is concerned, the transport of hydrogen in the form of ammonia is established and has been established again for a very long time, and there's an international trade around ammonia, so that's quite well established. And then finally, the localization. You're seeing a lot of demonstration projects for localization, referred to as hydrogen valleys or as microgrids, going on all over the world. There's an example very close to where I live in Edinburgh, in a place called the Port of Leith, where they're using offshore wind to generate electricity. The electricity is being used to treat wastewater. The pure water coming from the wastewater is then going to be electrolyzed, again using the same electricity to produce hydrogen, and the hydrogen is used in the port area to fuel cell ships, and to power waste collection vehicles. So there are ways and means of all of these things happening.
Okay, thank you for your overview, Stephen. Do you see any particular trends, Robert, in the various forms of hydrogen?
It does depend. I think the two major methods of getting the hydrogen will be gaseous, probably with the pipes, or trailers, or liquid. These are the two major trends that we are seeing. On the vehicle itself, at the end of the day, doesn't matter that much. The selection between gaseous, pressurized, or liquid cryogenic hydrogen will depend only on total cost of ownership. If you have it liquid, you can store more energy on the unit, and that's going to depend on the different equipments. But whether it's a fuel cell system or a hydrogen combustion engine, at the end use, it's still used up in gaseous form. So this discussion of liquid or gaseous form, or especially on the vehicle side, it only impacts the storage and some components in the conveyance of the hydrogen. So I don't think there will be a major discussion. I think it's going to be mostly focusing on the total cost of ownership, how it's easiest to get it to the station, to the site. Yeah. And overall, if you have very special applications where you require a large amount of hydrogen and energy density, then will be decided.
But I'm wondering, are there not two other factors that also come into play the loss of energy, so any leakage of hydrogen depending on the distribution. And also, I mean, when we're talking about electrolysis, we're using a lot of energy in order to get to the hydrogen. So those two factors, when we're aiming for zero emissions, which is the better distribution form, or less, produces less emissions, and losing any of the hydrogen. Do we have any comparisons there?
I mean, if we are talking about, again, it all comes back to efficiency, right? We do need to generate the hydrogen. If you want it clean, it's electrolysis, and then you are transforming from electricity into hydrogen, and you have losses there. So it is more efficient to use a battery electric vehicle or connect the vehicle to the grid. However, as we mentioned before, there are so many applications where this will not work. And also you have, for you to charge, you need to have the electricity on the site, which is the same. So whether you have a grid and you have electricity on the site to charge your vehicle, if that's an option,
so
if not, you need to have hydrogen.
I didn't mean the comparison between an electric battery and hydrogen. I meant of the hydrogen distribution systems, which have less energy consumption and also less loss of initial energy. Did you understand what I'm saying?
It's a big question with a lot of potential answers. It depends on which method you're using. So if you're moving, all of the methods that I described earlier all come with challenges that we've got to overcome. They are working, but they have associated challenges. So if you take the tube trailer method of delivery, you've got to pressurize the gas to put it into trailers to get any kind of quantity of gas delivered to a station. Even then, at typical pressures of 500 bar when these are delivered, you're only getting about 500 kilos of hydrogen on a given tube trailer. So which is fine for a small station, not many vehicles using it. Once you start to scale up and you see bigger vehicles like trucks and buses and more vehicles taking the gas, you get through that gas, 500 kilos, very, very quickly. And it becomes a logistical bottleneck. And hence why the stations that I mentioned earlier have converted to using pipeline supply. So there's that problem. Liquid as well, theoretically a great way of delivering, but the energy cost to produce liquid is very, very high. And then the energy cost to keep it cryogenically stored at it's minus 253 degrees centigrade is also very high. So you've got a lot of challenges. You also get energy losses. There's statistics that NASA produced that they lose 49% of the hydrogen just through boil-off from liquid, which is a lot.
Yeah.
But I think also with liquid, there is even more of a challenge. If we want to use it as the fuel of the future, the volume of liquid production available today is only 150,000 tons. The forecast demand for hydrogen in 2030 is 6 million tons. So it's a drop in an ocean. There is no way we can bridge that gap in the next 5 years. So it's a solution. It's not a perfect solution. Pipeline, I think you mentioned, pipeline for me is the most logical way of moving it around. And there's very little challenge with pipelines. I read a statistic somewhere recently that a study in Europe showed that around 90% of the existing natural gas transmission system can be can be used for moving hydrogen through the same transmission system. So the level of infrastructure investment is relatively low. Hydrogen's well known to the industry who also move natural gas. So not really many apart from regulatory challenges there. So yeah, there's a lot of different things about the methodology. Back to what you were saying about the cost of these things and the losses on it. That's, I think, why things like hydrogen valleys have become an important way of investigating how a system as a whole can work, and microgrids. And there's hundreds of demonstration projects going on worldwide around that, like the one I mentioned earlier. And when I think about it, the chat around those things is that if you think of energy security, which is a big deal today to the world because of various things going on, localized production of renewable energy, converting it into the energy that you want to do a job, brings a lot of energy security with it. So really,
and that's being explored in hydrogen valleys. Is that what you said?
hydrogen valleys and what's called microgrids, and they're even looking now at something called small nuclear reactors as a source of energy to produce electricity for exactly this purpose as well.
Okay, so thank you for that overview. Let's get to Parker and how Parker is facilitating the transition of vehicles to hydrogen solutions. Robert, tell us all about it.
Yeah, I think Parker, the advantage with Parker is that we have a wide range of products which are related to hydrogen solutions, whether we are talking here about mobile applications, so fuel cells and hydrogen combustion engines, but overall we do the whole supply chain. So we do electrolyzers and we do storing of hydrogen. So we are helping everybody. The advantage is we have this experience, decades of experience with the industrial sector and the mobile sector. So we are able to develop all these products to the highest standards which are required here. So, we are able to make sure that our products are leak-free and we can handle the hydrogen in a safe way. The other point which we have for these solutions, we require high filtration technologies. So Stephen was mentioning that the hydrogen is almost the same for hydrogen combustion engines and fuel cells. Reality is fuel cell requires very, very clean hydrogen. So we need to make sure we have good filtration solutions for those. And also air filtration is important. And I think last point, which we are talking about fuel cell systems, the thermal management of the unit. So within Parker, we are developing system solutions, high efficiency system solutions to make sure that the thermal management of the fuel cell system, the running temperature is controlled and the unit can run efficiently for a long period of time.
Okay, so just very briefly to finish, can you give us an overview of which system is better? We've got the hydrogen to the site. Which system is better if I'm designing the machinery? Do I go for fuel cell technology or hydrogen combustion engine? Can you maybe give us some examples there?
That's a big question. Personally, I think, especially for this market, hydrogen combustion engines will be sooner and will be potentially easier.
Yeah.
Even if you go here around the show, you will see a lot of demonstrator engines. The reason is you need to modify the engine. Everybody here has experience with the combustion engines, and you basically need to make some modifications to go from burning fossil fuels in it to burning hydrogen. There are optimizations which are required. The burning process needs to be optimized. We are generating a lot of water in the system, which can have an impact on durability of the whole unit. But overall, I think this is sooner. The only discussion here is it is not a completely zero emission solution. So you still have a small amount of CO emissions there and CO2 emissions, and you have NOxes, which needs to be filtered out, but you are reducing the emissions significantly. The fuel cell is also advantageous because that's going to be completely clean. And the other advantage is that it's generating electricity. So when you're talking about electrification with a fuel cell, you are basically just swapping out the battery. You are generating the electricity, which then can be used toward the electrification, which is a major discussion point. So I think both of those solutions have advantages. I expect the hydrogen combustion engine will be sooner, as you can see it here. But fuel cell, especially with the scaling on the on-road side, fuel cell is going to be a good option in the coming years.
Okay, thank you so much for the insights. Anyone from the audience, would you like to ask our experts a question? You can ask them anything about hydrogen. They're here.
I will ask one question.
Yes.
So durability of a fuel cell, or say So there's questions I get asked, right? The durability of a fuel cell used on a piece of construction equipment, a lot of shock and vibration, hostile environments, you need a lot of filtration. Do you see that as practical, like putting a fuel cell on a vehicle?
There are a lot of demonstrator projects which are ongoing, and as you say, definitely it's a very sensitive system. So you are going to need to have better filtration. The air filters which you need, especially in these dusty environments, you require new technologies there. And it is going to be more complicated to filter out the air and control the cleanliness of air and of the hydrogen. Similarly, on the vibration side and shocks, again, it is a sensitive system. But everybody's working on those solutions. I think we are going to get to the level where it can be used, and the membranes inside are also strong enough and they are not going to deteriorate. And especially, as I said, this technology is more advanced on the on-highway side. And once we are getting there close to mass production, you are going to require some additional modifications. But I think it's definitely feasible.
Thank you for your question. Any further questions from the audience? So maybe just to finish off, can you give us some examples of projects where you said the distribution was hit not on the nail and it was a perfect solution for our customer? I know it's sensitive as far as customer information is concerned, but just sort of the type of project and how it worked really well.
I thought this question might come up.
Oh, good. You prepared something.
So this is a company, Haringa, in New Zealand. And Haringa, I've worked closely with Haringa, producing hydrogen refueling stations for them. And they have got the contract to supply all of the heavy goods vehicle infrastructure across the islands of New Zealand. So a big project for them and for us at the time. Delivered on time, within the constraints that were expected. They're up and running already. You can see online that they're up and running. And you can just about make out here, part of the success story was Parker with their hybrid shell, which is these are another good thing about this one is we're progressively getting towards cookie cutter stations. Stations have been expensive to design and manufacture in the past. As we progressively get into standardization, the cost of manufacture these, the efficiency and the reliability of these stations is going to go up whilst the cost goes down. So a good demonstration project of where we've got some success running. And like I say, they're doing a great job down in New Zealand.
Thank you. Robert, anything that you can share with us?
Well, we are working on different projects. I think the filtration topic is critical, especially for if you are looking at fuel cells and the air filter from it. So there are different solutions that we are working on for dusty environment to make sure that that's basically the difference between off-road and on-road, the environmental conditions. So we are working at different media technologies to make sure that we are able to help our customers and basically protect this fuel cell.
Okay, what would you like to see within the next 5 years as far as hydrogen is concerned? What will help the technology evolve?
I mean, in this sector, I think regulation needs to come in. If we want to see a change, if we are expecting a change, regulation needs to come in for the emission standards. That is definitely going to push the whole industry first towards electrification and then also hydrogen implementation as an alternative. But that is missing. So I think that's going to be the biggest point which is required in this segment.
Okay. What would you like to see evolving in the next 5 years?
Funnily enough, nothing directly to do with refueling, but where my work has been in the past, it's hydrogen. There is now, we've got infrastructure around the world, but every company who owns a refueling station is saying, where am I going to get my hydrogen from? Mm-hmm. We need governments to commit to investing in, first of all, more renewable energy, and then downstream of that, electrolysis, so that we just get a supply chain going. That's what we need.
Well, thank you so much for your time. It's been very interesting to get this overview and some specific examples of projects with hydrogen. Stephen Learney, Robert Jozsa, thank you so much.
Thank you.
Thank you.
So if you would like to learn more about hydrogen solutions from Parker, then it's the Clean Tech Wall. Robert, you are based here on the booth, right? And Stephen, where can we find you today?
Oh, I'm going to go and hide, but Parker know where to find me.
Okay, fantastic. Up next, we'll be talking about thermal management, and that will be at 1 o'clock. So do join us again at 1 for electrification and thermal management to keep everything cool. Thank you for your attention. Thank you.